Question 3.3, and it's a tricky one. I think we'll be dividing this into a couple of parts. And this is a dynamic problem, so we're going to look at regulating pollution efficiently in a dynamic situation. And we've got the thing with this is that the pollutant accumulates over time, yeah. So it's a stock pollutant, we call it. And to keep things pretty simple, we're just considering two periods, at least initially. And we have an initial stock, S0, and then we have emissions, E1 and E2 in the periods. And we have the stock evolving as a function of last period stock and current emissions. Let me just make a little adjustment here. Okay. Assume part A. Assume there is a binding restriction on S2, the stock at the end of the second period. Calculate the ratio of abatement rates in the two periods. Okay. So we want to set up a problem with optimal abatement given a target for the stock at the end of the period, at the end of the second period. So we're going to have to set up a Lagrangian, aren't we? So what's this going to look like? It's going to include costs, which is what we want to minimize. And what are the costs? The costs are abatement costs. Abatement costs in period 1 are simply A1 squared. But we also need to allow for abatement costs, of course, in period 2. But what are they? Are they A2 squared? You might think so. But wait. The regulator, all else equal, would prefer to bear costs in period 2 than period 1. Why? Because of discounting. The discount rate is 5%, R, or it's R. So we're going to discount those costs by a factor 1 plus R. We don't care as much about costs in the future. Okay, but then we've got the restrictions. I guess we probably want a minus sign. So what are our restrictions? Well, we've got an incoming, we want to know how the stock is going to develop. And we know that for period 1, okay, I'm going to put an equal sign here, and this is going to turn into something else very soon. Okay. So stock at the end of period 1 is 1 minus gamma S0 plus E0. And what is E0? Well, it's E bar minus, sorry, not E0, plus E1. Emissions in period 1. What emissions in period 1? Their baseline emissions minus abatement in period 1. So that's plus 20 minus A1. Okie doke. So now we want to actually, that's the equation, now we want to put this into the Lagrangian, so it's going to be S1 minus that plus that. And this should be lambda 1 because this is the restriction for period 1. Because we've got a second restriction that says that S1 then feeds into and affects S2. S2 is equal to 1 minus gamma S1, and then plus emissions in period 2. And then once we've shifted things over, we end up with that. So this is our Lagrangian, and of course the actual restriction on, we're restricted on the final level of S2, so we're going to use that later. But that restriction is obviously going to affect what we do in period 1 as well as in period 2. And this setup captures that. Okay, calculate the ratio of abatement rates in the two periods. So it's not too obvious how to do this or what's going on, but basically you're going to take first order conditions, see what you can get out of it. Okay. So what do we take first order conditions in? Well, we'll start with the A's, the abatement rates. So first order condition in A1 gives 2A1 minus lambda 1 equals 0. So for an internal solution, 2A1 equals lambda 1. First order condition in A2 gives 2A2 over 1 plus R minus lambda 2 equals 0. Okay. So far so good, but we've got two equations in 1, 2, 3, 4 unknowns, haven't we? So this is kind of tricky. We need to pin things down a bit more. What do we do? Well, we've got S1s cropping up in two places here. Like, if you imagine taking the first order condition in S2, you're just going to get like lambda 2. What is that? But actually S2 isn't a choice variable anyway. So it doesn't make sense. Similarly, S0 isn't a choice variable. We can't take the first order condition in that. But S1 is a choice variable, isn't it? S1, I mean, effectively we're choosing it when we choose A1, but the way these Lagrangians work, we can still take first order condition in S1 and learn something. So let's take the first order condition in S1. We end up with minus lambda 1 plus lambda 2, 1 minus gamma, equals 0. So lambda 1 is 1 minus gamma, lambda 2. So we've got the ratio between the lambdas. So the shadow price of stock in period 1 is less than the shadow price of the stock in period 2. So we're more concerned about stock in period 2 than in period 1. Why? Because some of the stock in period 1 decays before you get to period 2. So we don't need to worry quite as much about period 1 stock. So how does this then pan out? We can substitute for lambda 1 here. So we get 2A1 is 1 minus gamma lambda 2, or 2A1 over 1 minus gamma equals lambda 2. Here we have 2A2 over 1 plus R equals lambda 2. So 2A1 over 1 minus gamma equals 2A2 over 1 plus R. So A1 over A2 is 1 minus gamma over 1 plus R. What's going on? We are abating less in the first period than we do in the second for two reasons. One, discounting. We just want to delay if we can. Two, decay. Because we've got this target at the end of the second period, it's favourable to delay for both of those two reasons. What's the ratio of the optimal taxes? Well, the optimal taxes are given by the ratio of the shadow prices, aren't they? So, for part B, lambda 1 over lambda 2, that's the same as the ratio of the optimal taxes, is 1 minus gamma. So you're going to tax less in period 1 than in period 2. Let me see, I can't find the question. Find the abatement rates in each period and the total cost of achieving the target if the target is S2 is less than or equal to 100. I'm going to pause there and take stock. Okay, so we're now actually asked to solve for the abatement rates in each period. How are we going to do this? I don't think I'm going to take you through this. I'm just going to explain. So, we've got an equation here which has two unknowns in it, A1 and A2. We want to solve for A1 in terms of parameters or known things and A2 in terms of parameters. So what other equations can we use? Well, we've got this one. If we put an equal sign there, oh, we need to be a bit careful, don't we? Because then that needs to be plus, and that needs to be minus. So we've got that equation. What are the unknowns here? We've introduced an unknown, S1. S0 is known, A1 we've already got. So we've added an equation, but we've also added an unknown. So now we've got two equations in three unknowns, and we're still struggling. But what about this equation? Actually, why don't I do this differently? Equals NORD. If we throw in this equation as well, then S2 is known, that has to be 100. S1 we've already got in the mix. A2 we've already got in the mix. So now we've got 1, 2, 3 equations in 1, 2, 3 unknowns. Straightforward linear equations. We just need to have a strategy for eliminating the unknowns and solving. I would suggest starting off by eliminating S1. Then we've got an equation. One equation in A1 and A2, another one in A1 and A2. Substitute to get rid of either A1 or A2. Work it out. Okay. And you should end up with C, half C, A1 is 9.19, A2 is 10.73, and total costs, NPV, from the perspective of the first period, is 194.1. Okay, another pause. Okay, I need these pauses, I'm getting tired. But this is super straightforward. Part D. What is the cost of holding the stock at 100 through the both periods? And then we can just look at this and say, well look, because to hold the stock at 100, we need to abate by 10 each period, don't we? That's pretty straightforward. The stock's 100, 10 decay, we need to add no more than 10. And again. So the baseline is 20, we need to abate 10 each period. 10 squared is 100 plus 100 over 1.05. So it's 100 times 1 plus 1 over 1.05. And my crib sheet tells me that is 195.2. Very straightforward, and another quick pause. And finally, part E, discuss how the above results change if we make gamma and R a lot bigger, 4 times bigger. It's effectively as if the periods are getting longer, where we've got a longer periods effectively. So what's going to happen? Basically, the difference in the taxes is going to increase. Difference in abatement rates between the periods is going to increase. The difference in these costs is also, of course, then going to increase. So the longer the periods, or the longer the time span as well, if you had multiple periods instead of just 2, if you had 50 periods, if these, because these look like years, don't they, with a discount rate of 5% and so on. If you had 50 years or 100 years and said, look, we just want to achieve the target at the end, you're basically hardly going to abate at all initially. Because why would you bother when it's all going to decay anyway by the end of by the target year? Okay, if you only care about the target year. So these results get hugely exaggerated then when you're focusing on this target year. And I'm going to stop this now, and then in the next video we're going to do F, G, H and I.